start giving me examples of prisms. And those are two different questions, aren't they? Can anybody give me an attempt at a definition of a prism? And this, don't feel bad. My hands never go up when I ask for a definition. Okay. Now, Addison?
A three-dimensional rectangle.
Okay, a three-dimensional, only a rectangle can be a prism?
Yes.
Oh, okay. All right, so a three-dimensional rectangle. Okay, so we'll start with that. There's a rectangle, yes? That obviously only has two dimensions. How do you make it have three dimensions? You got to draw some diagonal lines, right? We all agree that diagonal lines mean you're going backwards, yeah? Okay, so if I add the three diagonal lines, I get my prism, yeah? Everyone agrees? That's a prism? Okay, so what then would this be? What's that? Octagon, stop sign, yeah? Okay. What's that? It's a prism, isn't it? Is that a rectangle? No. But it kind of is, right? Because there's a rectangle. There's a rectangle. There's a rectangle. And what do two triangles make? Not necessarily a square, but always a rectangle, right? So isn't this just a rectangle? Everyone agree? Okay, what about this? A Toblerone chocolate bar. What's that? Why?
Because it's three-dimensional.
It's three-dimensional. So it's three dimensions that make it a prism.
Yes.
Okay, then why do I have this word here? Because aren't the things in the desert in Egypt three-dimensional?
Yes.
Are they prisms?
No.
What are they?
Pyramids.
Yeah, we don't call them the great prisms of Egypt, do we?
No.
What do we call them?
Pyramids.
Pyramids. So three dimensions isn't the answer either. So let's have a look here. You guys are smart people. What is the same in all of these? They're all three-dimensional. So we got to agree that the definition of prism must include it's a 3D object, right? Not an oddject. These have bellies and they bump into the next letter. That's how Mrs. McCarthy taught me to remember my B's and D's when I was printing. It was ironic because Mrs. McCarthy was pregnant, so she had a belly that bumped into things too. It was weird when I was in elementary school. All of my teachers had babies. My grade 2 teacher had a baby. My grade 3 teacher had a baby. My grade 5 teacher had a baby. My grade 6 teacher had a baby. My grade 7 teacher was a man, but his wife had a baby. It was very weird. Anyways. Oh, wait, I did that in the wrong color. We're doing pyramids, prisms, and blue. A 3D object. Now, what else? I almost wrote that the French way without the C. A 3D objet. So, what else? Why are these prisms? We agree they're all 3D. What else? You all have eyes. Addison.
They're kind of rectangular.
They're kind of rectangular. What do you mean?
Well, they're always long. They're always in a shape and then it extends.
That's what I'm looking for. What shape is right here?
Triangle.
And what shape is right here at the back?
Triangle.
What shape is here? And what shape is back here? Are they the same? Okay, what shape is here? What shape is back here? Are they the same? So what makes it a prism? It's a two-dimensional shape that has been repeated, yes? because this triangle is right there, all the way to the back. Everybody understand? All right. So a prism is a 3D object consisting of a 2D shape that repeats. Everybody agrees? Yeah? All right, it repeats. Now, what separates the 2D shapes? What do you mean separates it? Well, here I have two triangles. Yes, is that a prism yet? What makes it a prism? They're connected by what? What shape is that? A rectangle. What shape is that? What shape is that? So, a 3D object that consists of a 2D shape that repeats and is separated by what? Well, not just one, but separated by rectangles. Everyone agree? So let's do some drawings. First one's easy. Just draw a rectangle, 3 lines, boom. No problem. Anybody can draw that one, yeah? Triangle, same thing. Make a Toblerone bar. Triangle, 2 lines, done. Does a circular prism exist? A sphere? Is a sphere separated by rectangles? Is a cylinder a prism? You say yes. Why? What's that? Cylinder, yeah? What shape am I looking through? Now what shape am I looking through? So is the circle repeated? Is it separated by a rectangle? What shape's that? Is that rectangle between two circles? No. What shape is that? This isn't magic, Gersa Hill. What shape is that? Is it still a rectangle? Did I abracadabra it? Is it still a rectangle?
Yeah.
Okay. What shape is at the end of it? That's a rectangle. Gersa Hill, I don't want to put you down, but you made some pretty bold statements at the beginning of the year. What shape is that? What shape is that? Did that circle repeat? Did it start in one spot and repeat again over here? Are those two circles separated by a rectangle? So is it a prism? Yes. Okay. No, I appreciate that he wanted to know why. I have no problem with that. If you don't see it right away, you kind of gotta, right? All right. So how's a pyramid different? Because most kids, when I draw the Toblerone bar, you all know what I mean when I say Toblerone bar, right? Those triangle chocolate bars with hazelnuts in them. Shut up.
I ate 8 over the Christmas break.
Everybody knows what this is, right? 99 times out of 100, when I draw this, kids say, it's a pyramid. Is it? Do the pyramids in Egypt look like that? No. So how does a pyramid differ from a prism? Or how are pyramids the same as a prism?
A pyramid is a three-dimensional object made up of triangles.
Made up of triangles? Has to be triangles?
It's not separated by
It's not separated by a
a
rectangle? What's not separated by a rectangle? Addison?
It comes to a point at the tip, and it is a square at the base.
Has to be a square at the base?
No.
No. So a prism starts with a basic shape, doesn't it? Now, a prism does. So does a pyramid. Where is that base shape usually when we think of a pyramid? On the bottom, right? And it's usually a square, yes? When we think of the pyramids of Egypt, it's a square. They go up to a point, right? Halfway up, what shape is that? It's the square again, isn't it? But it's shrinking, right? As we go up to the point, what happens at the top? It disappears. Now here's the problem. You all want to call this the base. Why? Because it's on the bottom. Now if we were to go to the Louvre in Paris, they have a pyramid there, except that pyramid is upside down. It's sitting on its point. Why? Because it's an art museum, and you can do that. Where is the base of this pyramid? It's on the top. Why do we call it the base of the pyramid, even though it's on the top? What's the other meaning of the word base? It's the square. It's the shape that we are starting from. The pyramid is based on this square, and that square just shrinks. Does everybody understand? So just calling something a base in previous math classes meant the bottom, right? Because Mrs. Badcrumble always drew it that way for you, right? She made sure that if she wanted the area of a triangle, she made sure that you knew that this was the base and this was the height, didn't she? Right? But that's not the way the real world works, is it? And there's an example of it. Right? So, a pyramid, still a 3D object, consisting of what? Consisting of a 2D shape that does what? That repeats, but it doesn't just repeat. What does it do? Right, repeats and shrinks to a point. Now, they're easy to draw. We've drawn a bunch here. Draw, a sideways L, triangle, triangle. Egypt pyramid, right? We've all seen them. We know what we're talking about. I know I am being culturally insensitive because other cultures had pyramids too. But when you say pyramid, everybody thinks of Egypt, right? Even people from Mexico where there are pyramids. Even people from Nicaragua where there are pyramids. Even people from Brazil and Colombia where there are pyramids. Most people say, oh yeah, Egypt, right? I'm not trying to be culturally insensitive. It's just the easiest thing to say. Can we have others? Could we have a triangle pyramid? Could I start with a triangle on the ground and go up? Sure I can. Why not? Can I have a circle that repeats? What does that give me? A cone. Start with a circle on the bottom, dot, 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 dot. And that circle repeats but shrinks. Then I get the dunce cap, yeah? All right. Is everybody cool? Now, I've done something weird with all of these drawings. I have made the base on the bottom, haven't I? Right? And if the base is on the bottom, just like we talked about yesterday, where must the height go? Addison? Straight up, right? 90 degrees from the base. Agreed? So what happens if I do the Louvre pyramid? Now where's the height? It would be straight down. Does everyone understand? Height goes 90 degrees away from the base. What if I had a pyramid lying on its side? Now where's the base? It's on the left, right here, because that's the shape it starts from. Where's the height? To the right, 90 degrees away from where the base is. Does everyone understand? Well, the base is right here, and that's 90 degrees away from it. Right? The base is up and down, so 90 degrees is directly horizontal. Everybody cool? All right. So let's do some work. We're going to start with the easiest one of all. A regular rectangle prism. Okay? It's a cereal box. We all know what a cereal box looks like. We have cereal boxes in our house. And that's what it is, right? I'm going to call them Matthews. Everybody cool? All of you would eat Matthews cereal. It's all little plus signs and times signs. Tough to do a divided by sign. It's just a straight piece of stuff. And minus. Oh, it would be really easy. It's just X's and straight lines, because if you turn it sideways, it's divide. Could you make a square root? I don't see why not. I feel like Matthews would be brilliant. I think they would sell well. All right. So, now, of course, this shape is really what? If I want, first of all, I better discuss, I forgot. What's surface area? What's area? What's area? It's the amount of space inside the shape, right? This is a 3D shape, isn't it? So, isn't there space inside? Do we care about that when we're talking about surface area? No, what's the surface of something? The outside. So this has a surface area. Because it's got a hole in the top, is this surface area inside? Yes. What have I covered it up? Is the inside of this surface area now? No. So a good way to think about it is if you were to take your cereal box and dip it in paint, anywhere paint would go is surface area. Everybody understand? So we don't count the inside because the cereal box has a top. Everybody cool? All right. So, 2 ways to do this. One, you can memorize the formula because there are formulas for the simple shapes. Everybody understand? And if you were to look in your books, I can't remember where it is. I'm going to give you a sheet for this that has all the formulas in one spot. But for now, I don't want to do that because I want you thinking about it. Everybody understand? This is a simple shape. It has a formula. But what we're going to do is we're going to build that formula ourselves. All right? Now, since this is a prism, we know that it starts with what shape? It starts with a rectangle. Now, where would you say is the rectangle that starts this box? Where Matthews is written? Okay. So this is one rectangle. Does everyone agree? Now, we got to put some measurements on here, don't we? 8, 24, and 40. Where would the 8 be, logically? Which of those lines would be 8? Jacqueline?
The ones on the side.
The diagonal lines. There's our 8. Where would be the 24?
On the front, the bottom.
24. And where would be the 40? There. Everyone agree? Okay. Now, Braden has already said that the Matthews side is the first rectangle. What's the area of that rectangle? How would I find the area of that red rectangle? I'm going to use the highlighter instead, actually. How would I find the area of that yellow rectangle? Addison?
40 times 24.
So I could go 40 times 24, yes? And that would be the yellow rectangle. Agreed? Okay. Where's another rectangle? Pardon?
It froze.
But you can still tell me where another rectangle is.
Right side.
The right side. Everyone agree? And what would that area be? Sure, Addison, might as well.
40 times 8.
40 times 8. There's the blue one, yeah? Everyone agree? There another rectangle here? There's the green one. What would it be? 8 times 24. There's the green one. Now, since I want the surface area, what math would I have to do with all 3 of those? I've already done my multiplying. This is going to give me an answer, isn't it? And then this is going to give me an answer, and this is going to give me an answer. What do I need to do with all that if I want the surface area of the whole box? I got to add them up, right? Everyone agree? Okay. But does this cereal box have a back?
Yeah.
Does it have a bottom?
Yeah.
Does it have a left side?
Yeah.
So what do I got to do with all of these? Multiply the whole thing by 2. Everybody understand? Now, since these are all rectangles, they're all length times width, aren't they? Right? But when they're all in one prism, we can't call them all L and W, can we? Can we? Because L and W is only 2 dimensions. And how many dimensions does a prism have? 3. So we have to add a third letter here, don't we? What would logically that letter be? H for height, yeah? Okay. Where on here would you call the length? Where the 8 is, you would say is the length? Okay. So where would you say the width is? The 24. And where would you say the height is? 40. Do we all agree? Okay. Now, Ryland disagreed. Ryland said his length was 24, which would make, where would your width be, Ryland? Ryland would make that the width, which would make the height still 40. Agreed? What if I lay this cereal box down on its back? Would that change your idea of L, W, and H? It would, wouldn't it? But would it matter in your answer? Why not? It's multiplication and it's organization. So it doesn't matter, right? You can give these any letters. You can put the LWH anywhere you want. Now let's look at this. If I wanted this as a formula, it would be 2 bracket 40, everyone agrees was the H, yes? So H times 24 L. Could it be HW? Sure. Plus, what's 40? That's H again. What's 8? Well, we're doing the blue ones right now. So it would be W, because that's what Ryland said, right? But could it be M as L? Because there's my 8 and 24 anyway, right? And then what's this one going to be? 8 and 24, which are L and W. Does everybody see? Then, does it matter if I turn it around? Turn it upside down? Sideways? Doesn't matter, does it? Who decides where H, L, and W are? You do. Now, on the sheet I'm going to give you, it shows a prism, and it labels them H, L, W. Is that the way you have to do it? No, of course not. It's just for organization. Does everybody understand? Now, of course, we would use our calculator to work that out. Now, this is a little bit difficult because when you guys punch this into your calculator, you sometimes screw it up. Okay, so I want everybody to try to tell me this answer right now. Do not yell it out. Just try to punch this into your calculator. If you don't have your calculator, it's no big deal. Just try. I'll wait a couple more seconds because there's more than one way to punch this into a calculator. And then I will ask for an answer. Now listen, please. It's actually really important that you volunteer whatever answer you got. There's a reason that I'm doing this way. So even if whatever you have, there's a chance it'll be wrong, just say it. I'm hoping that somebody is wrong so I can do what I'm about to do. All right? So go. What do we got? We got 2,944. Anybody get something else? Braden.
2,884.
2,884. Anybody else?
I'm not saying, okay, this is a really big number.
Just say it. If it's just digits and you're uncomfortable saying all the millions, just say it.
It's
Just
117964800.
all right. Two of them are very close to each other, and one is way off. Yes? Okay. First of all, it is 2944. Now, listen, please. That's a whole lot of punching into your calculator, yes? How many of you have ever, when you're sending a text, sent the wrong word? All of you put your hands up. Don't be dumb. Right? Why? Did you mean to send the wrong word? You're going too fast, right? Now, look. Isn't this pretty close to 25? 24 is pretty close to 25, isn't it? What's 4 times 25? 100 plus a 0. So that's 1,000, right? And isn't that pretty close to 10? So that's 400, right? And isn't that 8 times 25, 200? About? 1,400 and 200 is 1,600, yes? Times 2, right? So I would need an answer somewhere around 3,200, yeah? So even though you guys got this, my calculator said so, because it did, would you ever write it down? No, because you took 2 seconds to make sure the answer would make sense. What you did was you did 40 times 24 times 40 times 8 times 8 times 24 times 2. That's what you actually did. Because you tried to do it all at once. Don't. Until you practiced, show some work. Do this. 40 times 24 is 960. So write 960 plus 40 times 8, 320. 8 times 24, 196. If you write it out, you cannot do it wrong. Okay? You can't have this happen. Everybody cool? Okay. Now, Braden, I have no idea how you got 2844.
I added it wrong.
Oh, okay. 192. Yeah. All right. Now, there's a lot of blank space here. We're coming back to this later. It's there on purpose. Okay? Turn the page over. Draw and calculate the surface area of a square-based pyramid. Well, we're going to draw this in 2 ways. One, we're going to draw it 3-dimensionally. Boom, boom. There's our square. How big is each side of the square according to our list? 32. So that's 32 and that's 32, yeah? Everyone agree? And then there's a triangle there and a triangle there. But what's on the left side of this pyramid? Another triangle. What's on the back side of this pyramid? So a pyramid is really a square with 4 triangles, yes? So this is the model, but we also draw something called a net. You can't go fishing without a net. Get it? A net. It's a name. Get it? But you're not laughing. Yeah, it is. So, this is the model. A net is what this would look like flat. So it would be this square, yes, with how many triangles? 4. 1 on each side. Does everyone agree? Now, there is a formula for this, but of course we're going to build it ourselves, right? So how do I get the area of that? It's length times width, right? Because it's a rectangle. But in this case, it's a square, right? So what do I know about these 2 sides? They're the same. So I'm going to call it B. So B times B would get me the area, right? But would a math guy ever write B times B? He'd write B squared. B, because usually that's the base, right? Everyone agree? Okay. So that covers that. Now we've got this triangle here, yes? Now this is weird. Because how many triangles do we have? 4 triangles. Who remembers, we talked about it yesterday, what's the area of a triangle? Base times height divided by 2, correct? Well, what happens when I got a 4 up top and a 2 down there? It becomes 2 over 1, doesn't it? So I would have base squared plus 2 base times height, yeah? But height, wait a minute. Addison says height measures from the middle straight up, yeah? Okay, so in the model, there's my height from the middle straight up, yes? But in this triangle, the height must go up there, yeah? Is that up the middle? No. Where's that? When this triangle is folded up here, where is this height? It's up here, isn't it? Now, we don't measure that as height, do we? If we were measuring the height of a mountain, we don't take a tape measure up the side of it, do we? So this can't be height, can it? So we can't use an H. So what we use there is an S. This is slant height. So we get b squared plus 2bs. And I know BS is funny. It's the slant height. Now there's a problem here, isn't there? Read the question. What does the question give us? The height. So in our model, we know that this is 65, right? The height straight up the middle. Yeah? And we know the whole bottom here is 32, right? I need this part of the triangle, the slant. How do I find that? If this is a height and this is a base, what angle do I know is right here? 90. What shape did I just make? What kind of triangle? Which means what am I allowed to do with it? Amelia, what am I allowed to do with a right angle triangle? A squared, B squared, C squared, right? But a lot of you are going to screw this up. How long is the bottom here?
32, but it would be 16.
It's only 16, isn't it? Right? Everybody understand? So I need this distance now, don't I? How do I find that slant? Well, it would be a squared, b squared, and c squared, wouldn't it? But in a pyramid, isn't our a squared the height? Isn't it? Right? So the slant squared would equal the height squared plus what? The whole base? Half the base. Base divided by 2 squared. But I don't want slant squared, do I? What do I want? Slant. So what do I have to do to this to get just slant by itself? What will get rid of squared and squared? What do I have to do to s squared to get it to just be s? This is algebra. What do I have to do? Square root. So the slant is the square root of the height squared minus the base divided by 2 squared. So what is the height here? What's my height of this pyramid? He waited patiently. Read the question. What's the height of the pyramid? 65. And then what do I have to do with it? Square it. Plus. What is the base divided by 2? 16. And what do I have to do with it? Square it. And then I square root to find the answer. What is it? $81. It's 81? I don't get 81. 65 squared plus 16 squared, and then square root the answer. And what do you get? Excuse me. 66.9, right? Which, for our purposes, what are we going to make that? 67. S equals 67. Now, can I do the surface area? Can I do the surface area now? What goes in for B? 32 squared plus 2. What goes in for B? What goes in for B? 32. What goes in for S? 67. And what is the surface area of this pyramid? Use your calculators to figure it out. What is it? Ladies and gentlemen, it's punching 6 number decimals or 6 numbers on your calculator. What is it? Part E.
5,312.
Thank you. Now you will notice I have not been putting any units, have I? Mrs. Bag Crumble would mark this wrong, wouldn't she? We have done area the entire time, yes? Even though it's a 3-dimensional figure, we're only counting area. So what are our units? How many dimensions do they have? The object has 3 dimensions, but how many dimensions does an area have ever? 2. Length and width, right? So this is going to be feet what? Squared. The prism is going to be centimeters what? Squared, because there's only 2 units. Let's do a cone. What's a cone? It's a circle, and then believe it or not, it's a section of a circle that is wrapped around that. Okay? Well, we all know what the area of a circle is. What is it? We must remember that. Addison?
I think it's like pi r squared.
Exactly. So a surface area must be pi r squared. What's r? What is it?
Radius of the circle.
Yeah. What is the radius?
It's half of the diameter.
Half of the diameter. What's the diameter?
The length across.
A line right through the middle of the circle, yes? Okay, so pi r squared, and it's plus part of a circle. Well, if it's part of a circle, since it's a circle, what must be involved in the area? What weird number has to be part of the area of part of a circle? What weird number is in the first part that has area of a circle? Pi. Pi must be involved here, yes? And since it's a circle, what else must be involved? Again, look at the area of the circle. It's only got 2 parts to it. What are the 2 parts of an area of a circle? Pi and radius. I'm dealing with a circle again, aren't I? So I must be dealing with what? Pi and radius. But this is pi r, right? Pi r squared, yeah? But isn't a cone just a pyramid? What did we have to remember when we did the pyramid surface area? We needed this slant height, didn't we? So does it not make sense that we need a slant height here? And since this is only part of a circle, it's not going to be r squared. It's just r and s for slant height. Does everybody understand? Okay. Do I know the radius of this cone? What is it? Radius equals 15. Do I know the slant height? No. But I know that slant height always equals square root of what? We just did it 2 seconds ago. Height squared plus base over 2 squared. Now the base here is this, isn't it? Isn't it? Okay, so that's a line straight through the middle of a circle, yeah? Right? What do we call that black line? Diameter, right? But I need half of that base. What do we call half the diameter? So when I'm dealing with a cone, the slant is h squared plus r squared. Everybody with me? So what's going in for h right here? 22 squared. Plus, what's going in for r? 15 squared. And that will get me a slant height. What is it? It's going to be a weird number. I only want 1 decimal. What's it going to be? 26.6. Yes? Yes? So now all of you have everything you need to try and punch that in. Yes? Are we going to write it out? Okay. So surface area equals pi. What's r? Which is 15 squared plus pi. What's r? What's r? 15. And what's s? 26.6. Now, something weird's going to happen. I'm going to turn off the screen. I want you to punch that into your calculator because we're going to get a bunch of different answers. And there's something I want to do with those bunch of different answers. Okay, go. We'll see. This is the last question. We'll see how long you take. So this has all been recorded. Now, remember that stuff I said about pi? Now I'm going to pause. What'd you put in for the rectangle?
20 for length and 31.
You put 20 there because it's 20 centimeters of pop can. And how did you get the 31.4 there?
I looked at, or I found the circumference.
The circumference, right? It's 2 pi r for the circumference, 2 pi r times the height. Now, when we say pop can, usually we think of it sitting up like that, right? But if I lie it on its side, isn't that still the height? Because height always goes 90 degrees away from the base shape, right? So we know, Braden just filled it in, 2 pi times 5 squared, because it's radius, plus 2 pi times 5 times 20. Now, if we're doing a math class answer, what's 5 squared? 25 times 2, 50. 50 pi plus, what's 5 times 20? Times 2? 200 pi. And what's 50 pies and 200 pies? 250 pies, yeah? Now, if I want the real life answer, I got to do 250 times pi. Now, in my head, pi is close to 3, right? What's 250 times 3? 750. So my answer has to be near 750, right? So even though Braden had all his numbers right, he said his answer was, I'm sorry, Braden, 4,000? 4,000. So now, he knows he's not right, right? Even though he has all his numbers right, my guess is he left the radius as 10. Yeah, so you left diameter as 10. So you did 10 squared and 10 times 20 times 2. Addison.
I understand why you have 2 pi r squared plus, then wouldn't it be length times width?
Yeah, but the length is the height of the cylinder, right? Right?
Yeah.
And the width, this is going to wrap around this circle, isn't it?
Oh, I see. Okay, it's the same thing.
Yeah.
Okay.
So 255, and then it comes out to be something like 753 point blah. I don't care about the point blah.
I got 785.
Oh, I thought it was 753. Okay, 785 point blah. I don't care about the blah. Everybody cool? All right, the quiz is 12 multiple choice questions. You got 15 minutes. Go for it. Yeah! You were doing it anyway. Bring it to me when the bell rings. We'll mark it tomorrow. Oh, no, you know what? No. Because I forgot. You got to make some conversions on here. And I haven't given you the sheet with all the formulas and the conversion values on it. So, what we're going to do is you can start on the assignment. Page 212 to 214. Now look, please, ladies and gentlemen. First two, not too hard, right? They're just regular shapes. Oh, but you can't see it in your photocopying. This is a 90 degree. So you can go ahead and put that in. What happens weirdly in D? It's a weird shape, right? If it's my favorite Tetris block. If none of this were here, would you know what to do? You would, because it's just this shape, right? Right? It's exactly the same as C almost, yeah? But there is this here. So figure it out. Everybody understand? Turn the page over. Is there any formula for that shape? No, but isn't it a rectangle prism and a triangle prism? Good. Any formula here? No, but isn't it a rectangle prism and a triangle prism? So try to figure it out. Are you going to get some of this wrong? Yes. Is it going to be frustrating? Yes. Learning to do things is frustrating. Try it. Don't leave it blank, because all these are shapes that we've already worked with, yes? And then I think the other ones are same thing. Just give them a shot. Obviously, we'll go over them tomorrow. We will go over all of this tomorrow, and you'll write your quiz tomorrow. Okay? Start now. You got 15 minutes. Get a good start.